In this lesson, we're going to be dividing by binomials, meaning two terms. And this is our lesson we're going to learn about synthetic division. You may choose to divide by either synthetic or long division. Everyone has to learn synthetic division because it's going to come up later in the year as a much quicker way to do some problem solving. Long division is something I want my students who plan to take calculus to learn, because you will use that in calculus, and I want you to have a little bit of experience with that before you get there. Anyone that wants to learn long division can, though, so if you want to learn both ways, feel free to watch both videos. Number 3, you'll see we have a trinomial divided by a binomial. So I want to, in the little box over there, you see it's the same as writing it like this. This is how our problems were for dividing by monomials. So you will see them written both ways, and I want you to recognize that. There are two terms in the bottom, so dividing each term by x and then by 4 doesn't work for these. You have to have a special way to do it. Synthetic division is a quick way to divide that it'll come in handy a lot for us later, so we're going to try and practice that. The first thing you do for synthetic division is you're going to take what you're dividing by and set it equal to 0 and solve. So x minus 4 equals 0. Add 4 to both sides. So x equals 4. Now, you take that 4 and you're going to put it in a little, I call it a box. It's a half box, a backwards L. I call it a box even though it's not. So that's my term. You can come up with your own term for it if you like. And I'm going to put that there. And then what you do is you list every coefficient from what you're dividing by. So, for example, I'm just going to go up here where I'm working. I have a 1, a 2, and a negative 24. So I would go 1, 2, negative 24. Now, notice that my original problem is in descending order. I had an x squared, then an x, then a constant. So if I didn't have that, I would have to account for that place value. Each of those is really a place value. And so if I was missing, let's say, the x, I would have to put a 0 where this 2 is. And we will do a problem like that, so hopefully that'll make sense to you. So now from here, I'm going to draw this line. Notice I'm just giving myself some space here, so I can write some numbers in that second row. So I'm going to draw a line here, and always with synthetic division, your first term gets brought down. So I'm going to put a 1 here. Then, and you're going to have to pay attention to this and maybe make some notes on how to do this. From here, I take 1 times 4, so I multiply here, and I get 4, so I put that 4 right here. So 1 times 4 is where that 4 came from. I then add this column here. 2 plus 4 is 6. So then I take and I multiply 6 times 4 to get 24. Then I add, and I have a 0. And we will do several of these, so if that pattern is confusing to you, you're fine. This part right here is always your remainder. Remember when you were dividing in grade school, think of when you first learned to divide 25 divided by 3. You had a remainder on that, which we wrote as a fraction, right? When you don't have a remainder, it divides evenly, we would say, and so then you have your answer. So here now is my answer. I have a 1 and a 6. When you divide, you will always be 1 degree less than what you started with. My degree in my original problem is a 2, my highest exponent, so my answer will be an x to the first. So this answer is 1x plus 6. It always goes in place order. So I start with the x, next would be the constant. Let's say it was x cubed. It would go x cubed, x squared, x, constant. So there's my answer. When I divide those two, x squared plus 2x minus 24 divided by x minus 4, the answer is x plus 6. And we will be using this a lot later in the year, which is why we're learning this process now. So we'll do a few more. I'm sure it seems a little bit confusing right away. You'll notice number 4 in your notes, 3 and 4 are the same problem, so we're skipping to problem number 5 on the back. Number 5 here then, same thing with synthetic. I always take what I'm dividing by, and I set it equal to 0 and solve. So x minus 5 equals 0. Add 5 to both sides, I get x equals 5. So I put a 5 here, and then I use my little box, and then I'm going to say each coefficient has to be represented. So I have a 1, a negative 2, and a negative 15. And I give myself some room there to write, and you bring down that first one always. So I bring down the 1. 1 times 5 is 5. Then I add, negative 2 plus 5 is 3. Then I multiply again. 3 times 5 is 15. And then I add. Again, this is always my remainder, so this one divided evenly again, which is great, right? So my answer, my original problem was a degree 2. I've divided one of those degrees out, so it's going to be x plus 3. The x is right there, the 3 is right there. And it might seem confusing because it's a new process you're learning, but you just have to do several of these and all of a sudden it's going to make a lot more sense. And when we use them later on in Advanced Algebra B, you'll see where we use this to help us solve some problems and see our roots and things. So number 6, again, x plus 2 equals 0. So I minus 2 from both sides. X equals negative 2. So over here I put my negative 2 into the little box, and then I'm just going to write each coefficient. So there's a 1, a 6, and a 1. Now this one is the first one that doesn't go in place value order. Notice I have an x cubed, an x squared, and where's the x? There isn't one. So if I was to write one in, I would have to write in 0x. Adding 0x isn't changing the problem, but it's giving me that place value. So as I list these numbers, I'm going to say 1, negative 6, and then because there's no x, I have to put a 0 in there. I have to represent that place value. And then I put in a 1. I'll leave my line there again and bring my arrow down. So I have a 1. Remember, you multiply here, so 1 times negative 2 is negative 2. I would then add to get negative 8. 8 times negative 8 times negative 2 is a 16. I add down the column. 16 times negative 2 is negative 32. And then I add here to get negative 31. Now we have our first remainder. So this doesn't divide evenly, which is fine. When I write my answer, remember I'm 1 degree less than what I started with. So really this is my x squared, this is my x, and this is my constant. So my answer is 1x squared minus 8x plus 16. And then how we write our remainders is I'm going to say minus 31 over what I originally divided by, always. So x plus 2. If you're confused on why that would be, let me just show you really quick. If you were going to take 3 into 25 when you were in grade school and you did this, you had to kind of guess which one worked, right? So 3 times 6 is 18, not big enough. 3 times 9 is 27, too big. 3 times 8, okay, 24. So this is how you did it in grade school, and you'd say 24, you subtracted here, you got a 1. Remember, that's 1 left over out of 3. So you would sometimes write and go decimals. You could maybe do decimals after this. But when you learn to write fractions, think of what right now we know 25 thirds is really 8 and what? 8 and 1/3. So here's where that came from. Here's the 1 left over out of the 3 you were dividing by. So that's how you've always done it, and it's kind of automatic in your head. Now that we're including variables, it makes it seem a little harder, but you're still taking this remainder and dividing by the original problem. And that's how you'd always set that up. So hopefully that helps you. The one I just did show you, this is long division here, so this is what we will be doing in the next video. Number 7, same idea. I'm dividing by x minus 4, so I say x minus 4 equals 0. Add 4 to both sides, so x equals 4. I'll put my 4 right here. And now notice I have x cubed, there's no x squared, and there's no x. So I'm going to list the 1 for x cubed, and then a 0 for x squared, a 0 for the x, and then the constant for negative 64. So you really have to watch that, because if they skip 2 place values, you have to put in that many zeros. Every time they skip, whatever they start with is where you begin. So x cubed is where we always start. I'm not going to put one in for x to the 4th or x to the 5th. But anything less than that has to be accounted for using our place value. So we put a 0 in that spot. So as I bring this down, 1 times 4 is 4. I add in the row here, or column here. So I get 4. 4 times 4 is 16. I add again to get 16. 16 times 4 is 64. And I add to get a 0. So I have another remainder of 0. And remember, we bring down this 1 degree less than this. So this would be my x squared, my x, my constant. So my answer is 1x squared plus 4x plus 16. Now the nice thing about this is if you really wanted to check your work, you can. You can take what you divided by, and if you multiply these two together, you should get that original problem. So x minus 4 times x squared plus 4x plus 16. Let's just do that quick to prove to you how this works, so you can kind of see that. I'm going to distribute the x to all three spots. So it'll be x cubed plus 4x squared plus 16x. Then I'll distribute the negative 4 to all three spots. So I'd have negative 4x squared minus 16x minus 64. So notice now I have x cubed, my 4x squareds add up to 0, my 16x's add up to 0, so I have x cubed minus 64, which is our original problem. So you can see how you could check those if you wanted to, and you'll see that your answer works. When you have a remainder, that'd be a lot harder to check, so that's not something you probably want to play around with. But when you don't have a remainder, that works out great. Last one. I really want you guys to try this one. I am trying to trick you. You're going to miss a 0, I think. So really pay attention to that and try this, and then you can unpause the video and see how you did. So in this one, x minus 2 equals 0, so x equals 2. I put a 2 here. And this is my first one where I have x to the 5th. So I have a 1 in the x to the 5th spot. There's no x to the 4th. There's no x cubed. And then I have a negative 3 for x squared. The one I think you'd miss is the x. The x is missing also, so you need another 0 right here. And then a negative 20 for the constant. So as I go through my synthetic, which hopefully is making a little more sense to you now, I bring down the 1. 1 times 2 is 2. Add the column. 2 times 2 is 4. Add to get 4. 4 times 2 is 8. I add to get 5. 5 times 2 is 10. And I add to get my remainder. Oops. To keep going one more time, sorry. 10 times 2 is 20. And then I add to get my remainder of 0. So this one divided evenly. And remember, we go 1 degree less than what we started with. I started with x to the 5th, so this would be x to the 4th, x cubed, x squared, x, and your constant. So my answer is 1x to the 4th plus 2x cubed plus 4x squared plus 5x plus 10. Now if you're wondering how I know they're pluses or minuses, it does depend on this number. So the fact that I wrote plus 2x cubed, if that would have been a negative 2, I would have written minus 2x cubed. So you do know by the sign of that number whether it should be positive or negative in your answer. Hopefully that's a nice review for synthetic. We will probably do one of these in class tomorrow just to make sure everyone's got this process down and see if you have any questions on it.